Now we go to our third measure, which is the Wasserstein distance. And here it only supports the continuous features. When it comes to the intuition or the analogy, it has a few other names such as earth mover distance, and I will describe shortly why it can be called earth mover distance, because it has a very nice physical interpretation. And unfortunately, it's in the range 0 to plus infinity, so you cannot that easily quantify how strong the drift actually is. So now, going to the intuition. It has beautiful physical interpretation, which is the Hallinger distance is just the amount of work needed to transform one distribution into the other. So imagine that the distributions are like piles of dirt, and you have one pile of dirt, which is the reference, probability density function, and you have the analysis probability density function. And if you were to transform one pile of dirt into the other, and you would calculate the amount of work, which is actual physical, physical equation for the work, and it would give you the Wasserstein distance between two distributions. And the way it's calculated mathematically, it's the area between the cumulative distribution functions. So CDFs that you see here. Quick reminder, PDFs, so probability density function just give you the density of probability function. So how likely is a given value to fall between any two of the starting point and the end point, and the cumulative distribution function is how likely it is for a value to be at or below a certain point. And here the shaded area is literally just the Wasserstein distance, so it's one of the easiest one to understand. And since I mentioned that it is the amount of work needed to transform one distribution to the other, imagine that you have piles that are almost on top of each other, or distributions that are almost on top of each other, except one of the distributions has a small pile of dirt, small outlier, very far away. It would still take a considerable amount of work to transform one into the other, just because there is some outlier really far away. And that means that this distance measure is sensitive to outliers, which might be a good thing if you care about outliers and you want to basically capture all of them. But of course, it can increase the amount of false positives if outliers happen in your data and they're quite normal. So something to bear in mind when you choose which measure to use. And the result here, you see that we don't have outliers in our trip distance feature. And there's only one place when we have an alert, something to look into, and we'll go deeper into the results later on.